Hello students. So today we will start our third chapter. So for the previous chapter, that is chapter 2, I will send the solution of the practice problem and you can try on your own if you can. Okay. So today our third chapter is our law of motion. This will be the first video. Okay. So our first topic is force. So generally we have different types of force, but for a force, if we say force, we represent a push or a pull. Okay, the force, we can say that force generally denotes denotes it denotes either push or pull. Fine. So whenever we apply force to a body, it tends to move. Okay, so it begins to move, and we or when we want to change the motion of an object, we apply force. That means if we want to change the motion means, suppose if a body is moving, then suppose we want to apply we want to make it in rest. Okay, or we want to bring the moving body into rest, so we will apply a force to opposite direction. Okay, or whenever there is something we want to move it, then we will apply some force. Fine. So we see that force can make a body move. Okay, so finally we see that force can, what it can do, force can we can say make a body, it make a body move, or we can say, or make a moving body, make a moving body stop. We can stop a moving body by applying force, or what we can do, suppose it is moving in very fast, then we can reduce the speed. Okay, or we can say, or make it move slower. Okay, or we can use that force so that the body can move faster also. Okay, or we can change the direction also, or change the direction of motion, clear, of a moving body. So what we can do, so force generally represents our push or pull, and by applying force we can make a body move, or to make a moving body stop, or we can increase or decrease the motion. Okay, or we can change the direction also. So concluding all this, so we can define, or we can give the force, the definition of force as, or we can say that force is an external, force is an external cause which changes or tends to change the state of rest or of uniform motion. Okay, of a body in a straight line, of a body in straight line. Clear? So you go through this definition. Okay, next we will move to the next topic, that is effects of force. Effects of force. So there are first, before going to this, we have to know what are contact and non-contact force. So generally force is our push or pull. Okay, and this force of pull or force of push can directly act on a body. We can either push a body or we can pull a body. Okay, so these forces of push or pull can directly act on a body, and they can also act on a body through a connector also. Suppose this is a block, you can understand this. So suppose this is a block, and here one we can say another pipe is connected, or something is connected. So if we apply a force here, okay, so if we apply a force at the point A, obviously this will also move. So we are not directly applying a force in the body. So this is the body B, but we are applying to a connector. So by applying to a connector, that force will transfer from our hand to that body. Okay, so they can also act on a body through a connector, or which may be rigid or non-rigid. Okay, so the force of push can act through rigid connector only, and however the force of pull can act on the rigid or non-rigid connector. That means if we apply the force of push, then it act through rigid connector only. So you have to note that the force of push, okay, the force of push, that means we are applying force by pushing the body. So it can act through a connector, but the body should be only the rigid one. Okay, so the force of push can act through rigid body, or we can say rigid connector only. And second point, the force of pull, the force of pull can act through either it can be rigid or non-rigid connector, non-rigid connector. Clear? For example, suppose we can push a car directly without our hands or by using handle, okay, which is a rigid connector. But however, we can pull the same cart directly without our hand or using a handle, which is a rigid connector, or using a rope also, which is not a rigid connector. We cannot push. Suppose this is a cart or something stone. Suppose one thread. This is a thread. So with the help of this thread, can we move this cart? If we apply a force here, so with the help of this thread, can this we can say wood move? Will this wood move? No. That means this thread is non-rigid. It is not a rigid one. So that's why I have written the force of pull. The force of push can act through rigid connector only. So as the force of push, we are pushing. Okay. So that means to push, this force can be transferred through a rigid connector only, and this connector is a thread. This is not rigid, so this cannot be done. So but if this connector, this is the connector, if this is rigid connector, then only we can push it. Okay, but if we want to pull it, so either it may be a rigid one, or it can be non-rigid one also. So for force of pull, it act through either rigid or non-rigid. Okay, so I think you understood this. So next we will go to examples of contact force. Example of contact force. Okay, so the force of push or pull, the force of friction between two surfaces, the force of tension generated in stretch string, or force of normal reaction, and force of extended during collision are some example of contact force. So examples of contact force, we can say the first we can say the force of push or pull, push or pull, or the force of friction, we can say the force of friction, the friction between any two surface. Okay, the force of friction between two surfaces. Number 3, we can say the force of tension generated in a stretch string. Okay, the force of tension generated in stretched string, stretched string. Then what we can say, the force of normal reaction, the force of normal reaction. Now what is normal reaction? If you see a block, any block, it weight acts vertically downward, and in the opposite direction there is another reaction that is called R. That is, this is our force of normal reaction. Okay, so likewise we will study all this thing. So fifth one, we can say the force exerted during collision. The force exerted during collision. Fine. So these are some examples of contact force. So now we need to understand them line by line. So first one is our frictional force. Frictional force. So what is frictional force? Whenever a body slides over a surface of another body, okay, so a force opposites its relative motion, okay, that means it resists its motion. So that opposing force is known as force of friction, or we can say frictional force. That means when a body slides over another body, or over the surface of another body, over the surface of another body, comma, a force opposes, opposes, opposes its relative motion, which is called, or that opposing force is known as frictional force, or we can say force of friction. Force of friction. Clear? So let us understand with an example. Suppose it is a surface. Over this surface, one wooden block is there. Okay. So over this surface, one wooden block is there. So its center of gravity is here. Suppose we have applied a force in this direction. Okay. Or we can say applied force. So let us write applied force. So a wooden block is placed on the top of the table. When a force acts on the block will move along the left direction. Okay. So if we apply a force on this block, it will move towards the left direction. And in the same time, a frictional force will also act. So suppose that means we are applying force, or we are pushing it, or pulling it, okay, and the wooden block will slide. So if we release the force, okay, then obviously the block will again stop, okay, it will not move. That means why it is moving? It is not moving. That means some force is applying or acting on the wooden block, and that opposes the motion, okay. So that is our frictional force. So if we apply a force on the block, you can see in the figure, so it will move towards the left. So instantly at the same time, a frictional force acts to oppose its motion. So and that frictional force will be opposite in the direction of applied force. This frictional force will be always opposite to the applied force. Okay, so in this direction there will be frictional force. Clear? Okay, so just you go through this. Okay, so in the next video we will discuss all the rest of the part, that is normal reaction, tension, then force extended during collision, and all these things. Okay, so let us kept itself today. So you go through this, and if you find any difficulty, then contact me. Okay, thank you.